Of all of the large-scale systems that impact the United States weather-wise, the North American monsoon is probably the least understood.
The southwest monsoon, sometimes called the Arizona summer monsoon, is a period of wet weather that usually occurs between mid-July and early September. And mostly in the states of Arizona, New Mexico, Utah, and Colorado. Sometimes it extends westward into Southern California, but that's the area that's most often affected by it. It's the wet period for the southwest U.S., and I would say that the southwest U.S. monsoon probably provides somewhere between 40 and 60% of the annual precipitation in that 1.5 month span over much of that area. Our snowmelt season is usually over by middle of May, and we have to rely on what's in the reservoirs from snowmelt to see us through the summer, unless we get a decent monsoon. I would say in most places, most of the time, it's beneficial and in fact vital to a lot of stuff, agricultural stuff and ranching stuff that goes on in the southwest U.S. Mm-hmm. They depend on it.
One thing that we do know with the monsoon season storms is the timing, that they'll start to build somewhere between 10 o'clock in the morning and noon in our mountains first, and then they won't cross I-25 until after 2 or 3 o'clock in the afternoon. They typically don't produce tornadoes, but we will see heavy rain, possibly some hail, and a lot of lightning from these. And if it's dry enough, we could also see some really strong wind from them. Some of the things that might go into the predicting the North American monsoon and when it starts is going to be water temperature, how the two different oceans interact with each other, because the North American monsoon draws moisture from both the Pacific Ocean and also the Atlantic. But specifically, the Gulf of California plays a huge role in when the monsoon starts to kick up. We have to see the Gulf of California's waters get up to a certain temperature before we start to see rains begin there in Mexico. And then once that happens and those waters continue to warm, then a lot of that moisture will get drawn upward as this big area of high pressure develops just to the southwest of Colorado. The position of that high determines what part of our state will see the rain. So one day it could be the mountains, one day it could be all on the eastern plains.
In the southwest part of Colorado, they depend a lot on that moisture. Here in the east, we don't have to have the moisture from Old Mexico coming across the mountains, because we have another source of moisture. For us, it's the Gulf of Mexico. But what's cool about the southwest monsoon is that we get the mid and high level moisture coming across the divide, and if at the same time we get the low level moisture coming in from the Gulf of Mexico, then we've got a deep atmospheric layer, maybe 25,000 feet deep, that is all moist. And that's when we get our really heavy rains. That's when the flash flood threat presents itself, and that's why the forecasters have to keep an eye out for the potential for very heavy rains. There's a criterion which determines when the monsoon has started, and that is on 3 days in a row, the dew point is supposed to be 55 degrees or higher. If that happens, the monsoon is said to have begun. Now, dew point is an absolute measure of moisture in the air, and it's just the temperature to which air has to cool before you get dew or cloud or fog. So it's an absolute measure of moisture in the air. And a 55 degree dew point around here in Colorado is reasonably high. So, for example, in summertime, if we have a high pressure system north of us, the clockwise circulation around the high, if it's north of us, will draw air in from the plains toward the foothills. And that air, more often than not, is the high dew point air, the air with a lot of moisture in it. And when that happens in the summer, and we have high dew points in the lowest few thousand feet, we get thunderstorms around here. And the reason for that is we have the mountains and the foothills to trigger the thunderstorms. The air tends to converge towards high ground in the summer when the weather's conditions are quiescent, and that pops the thunderstorms, as most people know who live here, over the foothills, over the Palmer Divide first.
Another thing that contributes to the storm development is going to be your landmass. So, for example, over Mexico, as that rain starts to develop, the vegetation starts to pick up. Vegetation sometimes can impact how warm it gets because it'll hold a little bit more moisture, perhaps help produce a little bit more humidity. So long as we have that in place, then we'll see some of these storms stay consistent. But if that changes, like we have humans who go down and tear down that vegetation, then that may have some sort of impact on the North American monsoon. Also, when you're talking about landmass, you're talking about our mountains. You know, somewhere up in the foothills may see a bigger impact from heavy rain than mainly what Denver would see. We'll see burn scars develop in our foothills, and you've got these steep hillsides that will carry a lot of water from one single cell from the monsoon down that steep hillside, and that water will rush into a low-lying area really quickly, and that flash flooding can happen in an instant, and that's what will take lives, and that's what will cause the mass destruction, much like what we saw in 2013. 1976 is a really good example of a monsoon season flood, and that's the flooding of the Big Thompson River.
One of the worst natural disasters in Colorado history occurred last night west of Loveland. Torrential rains east of Estes Park sent a wall of water down the Big Thompson Canyon between Estes Park and Loveland. The unofficial death toll is now 52, but officials fear that the number may be 3 or 4 times that great.
Specifically what happens in a monsoon storm is we'll see these really slow-moving cells. So they'll be producing, at their worst, 2 to 3 inches of water per hour in one location because they're moving so slowly. And that's a lot of water for land to take all at once.
Particularly if the flow is light aloft, that is, if the winds are not very strong. If the winds are, say, less than 10 or 20 miles an hour all the way up to where aircraft fly, that means any thunderstorms that form are not going to move very fast. And if we've got all this moisture provided in part from the Gulf of Mexico at low levels and from Mexico at mid and high levels, if we've got all that together with light winds aloft, then we have to watch out for serious rainfall.
So I did recently read a study that stated within the last 20 years there is evidence that our monsoon has become more severe here in North America. Whether that is from global warming, there is some evidence that points that it may be. If you've got warmer temperatures, then you're going to see your snow level potentially rise in the mountains, and you're not going to get the same kind of snowpack, and then that's just going to continue to amplify the conditions that we see when you have the monsoon rains that come in.
One thing that is quite likely with a warming planet is that the southwest U.S. will become warmer than it is now. It's already hot in the summer, and probably a little drier than it is, particularly in winter. So, and convection, as I think everybody knows, is very hard to pinpoint. It's spotty, it can be intense, but usually it does not cover huge areas. And because of that, because of the short lifetime and the small area covered, it's much harder to predict than large-scale weather features. So I think what might happen to the monsoon is quite up in the